Solving for a specific variable. Sometimes we may be given several pieces of information, and I may need to solve for a certain variable in a problem. So let's look at an example here. I want to solve your amount. We want to solve this for p. So let's say this is from let's see, the chapter 6, and it's the financial models section. So that's, I think, section 7, and this is a compound interest problem. And the amount is the amount in your account, or P is your principal, that's how much you initially deposit. R is your interest rate, N is the number of compounds per year your interest is compounded, and then T is in years. So you'll worry about that more in chapter 6 later in the semester. But let's say that maybe I know the rate and the number of compounds per year. So maybe I have this information already prior, and then I have a certain time in mind, or there's some sort of, you set your money in this account for so many years, and with this interest rate compounded at a certain amount of time, and you want to know how much it takes you to get $5,000 or something in your account. So what you want to do is you want to find what's the principal, how much should I deposit so that my money grows to $5,000 in a certain amount of time. Well, that might be a reason for why we would want to solve for P, but for now we're not, fussing with the actual application. We're just kind of playing with the numbers here, or not. Well, we don't have any specific numbers. All of these letters stand for numbers. We just don't know who they are, and we want to solve for P. So I want P equals. So I got that 1 plus R over N to the NT. All that junk's attached to P. I don't want it there. I want just P there. And how all that junk is attached to the P is by multiplication. And the opposite of multiplication is to divide. So we're going to divide both sides by that junk. Okay? And that's all there is to it for that one. Just divide both sides by 1 plus R over N to the NT power. And that's what our P is. So, if I had a certain amount that I wanted, and then I have a couple of options with the interest rate and number of compounds per year and time interval, I can kind of play with those and figure out how much my principal should be in order to get $5,000, for instance. Okay. How about, let's solve this for x. So we have ax minus b is equal to 0, and I want to solve for x. I'm going to make a note that a is not 0. If a was 0, then we would just have b, or negative b equals 0, and so that would force the b to be 0. Anyways, so I want to isolate the x, and already on the screen it says plus b, so that might be what we want to do. But you see it only says plus b on the left-hand side. Remember, we have to keep our equation balanced. Anything we do to one side, we got to do the other. So if I'm adding b on the left-hand side, I probably should do it on the right-hand side. Okay? So if I add b to both sides, the minus b and the b will drop out, and I'll have ax equals b. And the a is attached to the x by multiplication, so we're going to do the opposite operation, which would be to divide. Recall that at the beginning we said a is not 0, so if a is not 0, then we're okay to divide by it. Because if we divide by 0, then I don't know, maybe your computer is going to explode or something like that. So we've got to be careful. All right, so we're going to divide both sides by a, and we get x is b over a. And there we have it. That's all there is to it. Remember, the letters, the variables, they're just numbers. They act just like numbers. I know they look kind of big and scary, but they're just numbers. We just don't know who they are. They work just like them. All right, let's do another example. So let's solve. Your sum is equal to a over 1 minus r. So if you end up taking like calculus 2 or get into the sequences stuff at the end, you may encounter this formula. But we want to solve this for r. So let me back this up a little bit. So we're going to solve for r. So r is kind of in a difficult spot here. R is all the way down in the denominator, so we got to do all kinds of junk to get it free. If it was in the numerator, it'd be a little bit easier, but it's in the denominator, so that's going to be a little bit more complicated. So let's see what we can do to get it out of there. Maybe we might want a fraction bust. Okay. Okay, so we just have one fraction. It's just a over 1 minus r, so we only have one denominator, so we might want to multiply both sides by 1 minus r. Okay, and I do it this way, and specifically just to kind of help myself out when I'm doing the multiplication. If I'm doing a fraction, I'm going to put 1 minus r over 1, just so I can kind of remember that it's supposed to be in the numerator. If it's just a regular number like s or 5 or whatever it is, I don't have to put it as a fraction. I mean, you can if you want to, but I think less writing is better. Okay, and let's see what happens here. So we're going to see that the 1 minus r's cancel. You can, if you want, distribute the s through, but there's more than one way of doing this. But I think this is probably a little bit easier. Again, I'm trying to isolate the r. So if I multiply it by s, then I'm going to end up having to divide by s later on. So why don't we divide by s now? So we're going to divide both sides by s, and we probably should have mentioned s is not 0. Otherwise, the computer might explode. Okay, so we're going to divide both sides by s, and we have 1 minus r is equal to a over s. And we're kind of out of room here, so we're going to draw arrow to kind of guide the reader to where we're going. Going to rewrite again, just so we didn't do any steps along the arrow here. Again, we're trying to isolate the r, so we're going to get rid of its neighbor. It's 1, positive 1. So the opposite of the adding 1 is to subtract 1. So we're going to subtract 1 for both sides. And then we're going to be really, really clever here, because we're lazy also. 1s over s and s over s. Now, what in the world is s over s? You might want to pause your video to think about it. What is s over s? Ask yourself, what's 2 over 2? What's 3 over 3? What's 4 over 4? It's 1. So, and why I did this is so I got a common denominator. And I'm just trying to save myself some time, too. All right, so we got 1 minus s over s, which is just 1 minus 1, so that's gone. And we got negative r equals a minus s over s. And we wanted to solve for r, not negative r, so we have two choices. We can divide both sides by negative 1, or we can multiply both sides by negative 1, and we would get the same thing. And that's just going to change everybody's sign. And we get r is equal to s minus a over s. And there we have it. We've solved for r. Okay, let's do one more. So let's solve. I'm going to guess that this is velocity is equal to gravity times time minus v naught, and v naught is your initial speed. So possibly this is, I'm just going to take a guess. I'm not a physicist or anything like that, but maybe we shot something up in the air. Maybe a football was thrown up in the air, and then why it's negative g for the negative gravity, the gravity's pulling it down, so it's working against it. So we'd have positive velocity going up, and then gravity's working against it. And let's see who they want us to solve for. Maybe they want to solve this for time. So maybe a common question is at what time is the velocity 0? Meaning, at what time do we reach the peak? You know, we stop going up, and we're going to start going down. So at that instantaneous moment, we have 0 velocity. So we might be interested in that time. And I might be interested in, well, if time is this amount, what is my velocity? I don't know. But let's go ahead and solve for t. So we're going to subtract v naught first. So usually we want to get the neighbors away first, so the neighbors are with addition and subtraction. So we're gonna subtract v naught from both sides. So I've been saying it, but maybe I'll specifically point it out. So you see how you got that little O. This is VO. That's sometimes your initial condition, and that's just fancy for starting point. So that would be our starting speed. So we're going to subtract v naught from both sides. So v minus v naught is negative gravity times time. Negative gravity is attached to time by, or negative g is attached to t by multiplication. The opposite of that would be divide. So we divide both sides by negative g. Okay, and then I did one other thing here. I don't like the negative in the denominator, so I can go ahead and divide the numerator by that negative. So just move that negative up. So the v naught went from negative to positive, and the v went from positive to negative. All right. So that's it for this one.